Welcome to The Explainer. Today, we're diving into one of the most incredible and honestly underappreciated systems in your body, digestion. We're going to follow the entire journey of your food, from the very first bite all the way to how it becomes the fuel that powers your every thought. I mean, you don't even have to think about it, right? It all just happens on autopilot. But beneath the surface, it's this beautifully complex process. Our bodies are running 24/7. So let's trace that exact path our food takes and see what's really going on in there. So, this is our basic roadmap. The main route, the GI tract, goes from the mouth, down the esophagus, into the stomach, snakes through the small and large intestines, and then, well. We'll follow this path from start to finish, and along the way, we're going to meet some really important helper organs that make this whole shebang possible. Okay, let's get into it. Section 1, the breakdown begins. Our journey kicks off the very second food passes your lips. And right away, two critical things start happening at the same time, a mechanical breakdown and a chemical one. You know, everything inside your mouth is designed with a purpose. That hard palate on the roof of your mouth, it gives your tongue a surface to mash food against. The soft palate in the back, that swings up to block off your nasal passages when you swallow. And then the pharynx acts like a traffic cop, making absolutely sure that food goes down the right pipe, the esophagus, and not into your airway. It's all about breaking things down and getting the food safely to its next stop. After that quick trip down the esophagus, the food lands in the stomach. And this thing is this incredible J-shaped muscular bag that's designed to stretch and can hold about 1.5 liters of food and liquid. Honestly, the best way to think of your stomach is as a high-powered blender. It's churning and squeezing, all while mixing the food with some seriously powerful acids and enzymes. This whole process turns solid food into this thick, soupy mixture. And it's got a name. It's called chyme. Getting the food to this chyme state is crucial for the next, and maybe most important part of the journey. All right, let's move on to the star of the show, the small intestine. This is where the real magic happens. I mean it. It's this long, coiled-up tube where the vast majority of nutrients are finally pulled out of our food and into our body. Now, what's so cool is that the small intestine isn't just one long tube. It's actually got 3 very distinct sections, each with a specialized job. First up is the duodenum, where that chyme from the stomach gets hit with a cocktail of enzymes to finish digesting. Next is the jejune, which is the main spot for absorbing most of those nutrients. And finally, you have the ileum, which takes care of very specific things, like absorbing the super important vitamin B12. But here's the thing. The small intestine is not a solo act. It gets critical help from several accessory organs. And what's wild is that food never actually goes inside these organs. But without them, digestion would pretty much grind to a halt. These are the real behind-the-scenes heroes of digestion. We already met the salivary glands back at the start. But now the liver, gallbladder, and pancreas jump into action. They create and send bile and enzymes right into the small intestine when they're needed. For right now, let's really zoom in on one of these key players, the pancreas. The pancreas is just incredible. It's like it's moonlighting, doing 2 totally different but absolutely vital jobs. On one hand, its exocrine side is pumping out digestive enzymes, special ones for carbs, fats, and proteins. At the exact same time, its endocrine side is releasing hormones like insulin and glucagon right into your bloodstream to control your body's blood sugar. It's a chemical factory and a master energy regulator, all packed into one. So we keep saying the pancreas pumps out enzymes, but what are they really? Well, think of them as tiny, super efficient workers. They're biological catalysts, which is just a fancy way of saying they make chemical reactions happen way faster. We're talking millions of times faster than they would on their own. Without them, digesting a meal could take, well, a very long time. Okay, so we've broken the food down and we've absorbed the nutrients. But what happens next? How does the body actually turn a piece of bread into the energy you need to blink your eyes? This is where we get into the fascinating science of metabolism. You know, a lot of people hear metabolism and just think burning calories, but it's so much bigger than that. It's the grand total of every single chemical reaction that keeps you alive. It's the master process that converts food into energy and into the building blocks for everything your body needs to do. And your metabolism basically has 2 opposite modes of operation. So you've got 2 sides to this metabolic coin. On one side, you have catabolic reactions. That's all about breaking complex things down into simpler ones, which releases energy. Digestion itself is a perfect example of a catabolic process. On the flip side, you have anabolic reactions, which use energy to build complex things up from simple ones, like when your body stores extra sugar for later. Your body is constantly, and I mean constantly, balancing these two processes to manage its energy. So how do we get from a simple nutrient to actual usable power? This is where it gets really cool. Inside almost every cell in your body, a process called cellular respiration is happening. The mitochondria, you probably remember them as the powerhouses of the cell, take those nutrients and use them to make ATP. Just think of ATP as the universal energy currency for your body. It's the battery pack that powers everything. A huge part of this process involves these little shuttle molecules, NADH and FADH2, which carry energy to the final assembly line, the electron transport chain, to make the bulk of that ATP. This is it. This is how food becomes life. Of course, this amazing system needs the right kind of fuel to run. Your body needs a whole variety of these raw materials, and some of them are called essential for a very simple reason. Your body can't make them itself. You absolutely have to get them from your diet. That includes things like that vitamin B12 we talked about, which, as we saw, gets absorbed way down at the end of the small intestine in the ileum. Okay, we are on the home stretch now, the final leg of our food's journey, cleanup and control. After all the good stuff has been absorbed, what happens to the leftovers? And who or what is in charge of this unbelievably complex operation? Well, anything that couldn't be digested and absorbed in the small intestine gets passed along to the large intestine. Its main job is basically recycling and conservation. It sucks out most of the remaining water from the indigestible stuff, and then it compacts what's left into waste, getting it ready for, removal. It's the final critical cleanup stage. So who's running this whole show? Who's the conductor of this amazing orchestra? Well, it's the enteric nervous system. It's this huge, sprawling network of neurons that's literally woven into the walls of your gut. It's often called our second brain for a good reason. It can pretty much run the whole digestive show on its own without needing instructions from the brain in your head. It tells muscles when to contract and glands when to release their juices. It's absolutely amazing. And the grand result of this entire, finely tuned system? Energy. The energy that fuels our lives. We measure that energy in calories. And to power everything from that second brain in our gut to the main one in our head, most adults need somewhere in the neighborhood of 2,000 to 2,500 of them every day. I mean, when you step back and think about it, from the very first bite to that final little spark of ATP energy in your cells, the digestive system is a true masterpiece of biological engineering. It's all kept in this perfect, delicate balance by a constant chatter between hormones, that second brain in your gut, and signals from your actual brain. It's an incredible reminder of the complexity that's humming along inside of us at every single moment. Thanks for joining me on this explainer.